Hello, everyone. Welcome to Mathematics with Shahab Yaqub. So in today's video, we'll be focusing over an AS level paper, which is Pure Math P1. And this is of May, June 2024, the first variant. Now, this is a walkthrough video in which the questions are already solved, and we'll be going over the solution. The whole purpose is to go over the paper as quickly as possible so that you can save some time and do some extra effort and practice some more papers so that you are fully prepared for the upcoming exam. Now, let's look at question number 1. Now, let me also highlight what topics are being asked in a particular question. So first of all, in this question, we see that it's about quadratics and it's about exact solution of a disguised quadratic equation. So basically, it's quadratics, it's completing square method, and it is about disguised quadratic equation. Now, just have a good look at it. The first question, as usual, is getting it into the completed square form. All you have to do is to follow the process. You have to show the complete process. You should not leave out anything. And this is the format, this is the form that you are achieving. The second one, hence. Now, this is related with the first part. You have to use the first part. Hence, find the exact solutions of the equation such and such. Now, this equation and this equation is exactly the same. Instead of y square, we have y4. Instead of y, we have y square. Actually, the variable is changed. It's x power 4, x power 2. So now the first step, that's on the left-hand side. Solve this equation, which you already found, but using the completed square method. That is a must. When you do that, you get two answers. First of all, when you take the square root, make sure you apply the positive and the negative sign. You get two solutions, y equals to -1, y equals to +5. Now the second part is related with this particular equation, and at this point, you have to realize that this is a disguised quadratic equation. The y square has been replaced by x4. The y has been replaced by x squared. So in other words, y or m, I use the symbol m, you can use the value y. M is x squared, m squared is x4. It's the same equation. Naturally, I'll be getting the same answer, but what is m equals to? M is x squared. So you can write y also. Y is equals to x squared. Therefore, y is equals to plus minus square root of 5, y is equals to plus minus square root of -1. But remember, square root of -1 does not exist. We cannot take square root of a negative number, and you will find the answer. So that's how question number 1 is done. Let me focus on question number 2. This is about trigonometry. It's about a sketch. It's about a function, and it's about the transformation of function. So now let's look at the first question. It says the diagram shows two curves. One curve has this equation. The other one has this equation. It was not labeled. You have to decide that this equation over here, that is sine x. And the big one over here, that is y is equals to fx. Now it says in order to transform the curve is first reflected in the x-axis. Describe fully a sequence of two further transformations which are required. So the first thing is that they have reflected it in the x-axis like this. So the first one, reflection in x-axis. Step 2, stretch parallel to y-axis, because look at this. This amplitude is 1. Now, if this amplitude is taken from here like this, it's 3 units up, 3 units down. So the amplitude is thrice. And then what else is there? We have this thing that is, what about the period? So we say the period remains the same. If I start from here, 3 pi by 2 to 7 pi by 2, the period is still the same. So there is no change. There is no stretching along the x-axis. What about translation along the y-axis? Yes, there is a translation. Which formula is this? This is the difference between maximum and minimum. Its average will give us the amplitude. You can even count it down. You can take the maximum, you can take the minimum, you can count the number of units, half it, that is the amplitude. Find fx in terms of sine x. So there is a negative sign for step 1. There is a 3 for step 2, stretch parallel to y-axis. There is a -2 for a vertical translation of 2 units down. Make sure that you label and mention the TV, the translation vector. So that's how question number 2 is done. Now let's move to question number 3. Question number 3 is about binomial expansion. Now it says the coefficient of x cube in this expansion is 160. Find the value of constant a. This is of the format a plus b raised to power of n. So this is NCR, a raised to power of n minus r, b raised to power of r. Since we need the coefficient of x cube, so the power of x should be 2. Whatever power is left, 6 minus 3 is 3. That goes over here. Simplify, separate out the coefficient. That coefficient should equal to 160, and the answer comes out to be 2/3. The value of a is 2/3. Now here is the tricky part. The tricky part is, hence, find the coefficient of x cube in the expansion of the bracket from above, multiplying with 1 minus 2x. Now realize over here, if there is a 1, there is a -2x, there is a constant term, there is an x term. In order to get the coefficient of x cube, what do I need? I need an x cube over here that will multiply with this constant. At the same time, I would be needing an x square over here that should multiply with this. So that is the thing that is missing. Now, some people, they think that, okay, the word hence is used, so only the above result is used. That's not true. The word hence means, yes, definitely, let me just minimize it. Yes, definitely use answer of previous part, but no one is stopping you to find something else also. No one is stopping that. So it's done in 2 parts, and that is very obvious. Also need the coefficient of x squared. Go ahead, apply the same process, find the coefficient of x squared, plug in the value of a, and this comes out to be 540. So now this is the x squared term. It multiplies with the x. Look at the color coding. This is 160 multiplying with 1. And you add it all up, you get this coefficient, which is -920. So now this thing is done. The next one. Now the next one, this is about differentiation. And it's about the concept of first principle, that how is the concept of differentiation is obtained. Let's say you have a curve and you are finding the gradient at this point, and then there are other points along the way and you want to draw a tangent. So if the points are the closest, you will get the best possible straight line and the gradient of that tangent. So now over here, the equation of the curve is y is equals to fx, which is this equation. The following points lie on the curve. Non-exact values have been given correct to 5 decimal places. Now, when we plug in 2, we get an exact value. If we get non-exact value, that's the x coordinate. I'm focusing on the y coordinate. So for non-exact value, you have to round it off to this level of accuracy. The first thing, find the y coordinate, just plug in the value. Show every single step. It's like show and tell. Whatever you have learned in preschool years, that's coming back to reality. So now y is equals to this value. You just write it down. 1, 2, 3, 4, 5 decimal, all good. The table shows the gradient of the chords AB, AC, AD, AF. So that's AB and AC and AD and AF, and AE is missing. So now these values are given. You have to evaluate this. That's simple gradient formula. You get this answer. Now look at the working. The working is, let me minimize it. The gradient is starting from 6.2501, 6.2511, 6.26, 6.3566, 7.288. Now look at the value. A and B are the closest. This is 2. This is 2.0001. This is a little bit further. This is little bit further. This is little bit further. This is very, very further. So now which chord will give us the best possible value of gradient? That is this one, AB. Find the value of f prime of 2. That means the gradient, this is the concept of gradient of tangent to the curve. That is equals to dy by dx. So the closest value will give us the best possible gradient, the best possible value of the derivative, and that is the answer over here. So that is the concept over here. The next question, that is, I think, kind of straightforward. That is about trigonometry, that is about identity, and that is about an equation. Now, prove the identity. I think it was too simple. All you have to do is to plug in the value. Sine square is 1 minus cos square. Take negative common out. Always remember, common rules the day. Common is a very, very important property. So take common out. Even take C common out. Now, I deliberately did not take C common out in the beginning. I don't want you people to overburden yourself. Take it easy. Add an extra step. Nothing is wrong with that. It does not have to be perfect in the sense that you do everything in one step. Nobody's forcing you. I deliberately took negative common out. Then I took a C common out. This cancels out. We get negative C. In other words, this left-hand side is identical to. That is why we use the terminology identity. This left-hand side is identical to negative cos x. Now, keep your eyes open. So let me write it down. Keep your eyes wide open. You need to look at questions very, very carefully. Is this the same thing as before? Some people would just take it for granted. Yes, it's the same as before. No, it's not. Look at the denominator. This is 2 plus 2 cosine x. Look at the denominator, 1 plus cosine x. So what have I done? I first took this 2 common out. I shifted this 2 to the other side. 2 over 4 becomes half. Now this left-hand side is the same as part 1. That is why the word hence is used. But this equals to negative cosine x. Negative cosine x is half. Cosine x is negative half. And then we apply the 4-step method to solve a trigonometric equation. We define the quadrants, we write the range of values. If it's not modified as it is, if it's modified, for example, 2x, the endpoints would be multiplied by 2. We would be talking about 2 revolutions. Find the basic angle alpha. And I think I should write over here, alpha is the basic angle, the acute angle with x-axis. And then after you find alpha, depending upon the quadrant, you write the answer. So in the second quadrant, theta is 180 minus alpha. In the third quadrant, theta is 180 plus alpha. You don't have to draw the angles. You just have to follow the process thoroughly. And this is the answer. Now, question number 6, I think this one was slightly tricky, I think. So this is functions. And let's focus on that. The first thing, the function, f is defined by fx is 2 over x squared plus 4, x is lesser than 0. So this is the domain that was given. The diagram shows the graph. On this diagram, sketch the graph of f inverse x, show any relevant mirror line. So a function and its inverse, they are reflection of each other in the line. Y is equals to x. This is y is equals to fx, that is given. And this one is y is equals to f inverse x. All you have to do is to show the reflection. Let's say this is 1 point that gets reflected over here. So now the knowledge is that if I draw a perpendicular this way, all the way over here, and it's going all the way over here. Of course, it's not going to be exact. It's going to be approximate, but the concept of reflection should be very, very obvious. Similarly, if I draw another point over here, let's say, so that point is over here. And then if I draw a third point that is at the end, so that third point is like this. So more or less, I know the question is a little bit pushing towards the diagram. They should have given more space. This thing goes like this. So just double check like this, like this, like this. Yes, it's a reflection. Find an expression for f inverse. It's the same old method. Do write this thing out. Y is equals to fx, f inverse y is equals to x. I think I forgot the bracket over here. So let me write it. Make your mistakes very, very visible with the red pen, with the green pen, with some other colored pen. So now over here, this was the tricky part. The domain has a square root, not the domain, the x when we make the subject. For f inverse y, that has a square root. So now is it the positive sign or the negative sign? Now remember, when I taught you people quadratics in my regular class at my college. So the thing was that if we are talking about a quadratic function, and if we go left of turning point, the square root has a negative sign. If we go right of turning point, the square root has a positive sign. So that is why, excuse me, I have applied this negative sign over here. Okay, if someone is doubtful, they can have a negative sign, they can have a positive sign. They can choose one value from here, plug it in over here. One of them will give the correct answer according to the quadrant, according to the positive negative sign. The other expression will not. Solve the equation fx is equals to 4.5. Again, you get two answers, but what needs to be done? Keep your eyes wide open. If x is less than 0, we are looking for this range. We are looking for fx. So for fx, there are two answers. Accept the negative, reject the positive. So it's not always that negatives are bad. It's not always positives are good. It all depends upon the function, the domain of that function. Explain why f inverse x is equals to fx has no solution, because it does not meet the line y is equals to x. It is necessary that if a graph and its function, let's say a graph goes like this, a function goes like this, it is necessary that the function and its inverse will meet at the line y is equals to x. There is no meeting with the line y is equals to x of y is equals to fx. They are not intersecting. That means definitely the inverse will not be intersecting with y is equals to x. Therefore, these two functions will not be intersecting with one another. As simple as this. The next question, this is about circular measure. Make sure your calculator is in radian mode. So when we use sine and cos and tan for basic sine, basic cos, basic tan, or sine rule or cosine rule, or the formulas s is equals to r theta, or the formula area is half r squared theta, it is necessary that the angle should be in radians, calculated in radian mode. Now it's a pretty simple question. It says in the diagram, AOD and BC are parallel straight lines. And what else is there? Arc AB is part of a circle. This is the angle. This is the radius. And there is this right angle triangle over here. There is this quarter circle over here. Why quarter circle? Because this angle is 90. This is 10. This is 10. Therefore, this is a quarter circle. The first thing is show that theta is this much, correct to 4 decimal places. Now, if, for example, someone is unable to find theta, let him skip this one mark and proceed with the rest. Do not waste your time. So that is again another important thing that you need to consider, because all these things to get control of your nerves, that is what will make you achieve an A star. An A, it's not just about math. It's much more than math. So do not emphasize on one part. That means if, for example, you are unable to solve it, just go ahead. Leave and just go ahead. So that's the main thing. And come back to it later. So I'm writing it down so that it is registered in your head. So that is the thing that I'm focusing on. So now, why have they mentioned that these two lines are parallel? Because if this line is cutting through it, that's the Z shape, the famous Z shape, the alternate angle. So this is theta. So now this 15 and this is 15 and this is 10. So this is opposite of theta. This is opposite of 90. Therefore, I use sine and I found the value of theta. The second one, find the perimeter and area of the shape. Now the perimeter, let's focus on that. We have to find the arc length. We have to use Pythagoras or sine, cos, tan to find BC, whichever one is relevant. We have to find the arc length, add these three, plus 10 plus 15, and you will get the perimeter. That's the first thing. The second thing, the area. Find the area of the sector, find the area of the triangle, find the area of the quarter circle, and add it up. Now look at my working. Look at the simplicity of the working. Look at the clarity of the working. Sector, I mentioned radius, I mentioned the angle. Arc length, I have written in red color. I have not evaluated it as yet. Now for red color, I mean, of course, you're not going to write in red color. This is for you people. So the arc length, that is in red. The area is in blue. Evaluated. I mean, I wrote it down, but did not use the calculator at this point. Triangle, we have two lengths. And let me just change this thing over here. So now over here, I have changed this. This is the working for the length, that is BC, and then the area. And for quarter circle, that is the arc length, which is 1/4 of the perimeter of a circle. Area of quarter circle, that is area of quarter circle, that should be 1/4. I think I missed it out and maybe calculated it properly. So this is 1/4 of pi r square. And let me write, I think over here I've written it correctly. It was just a small slip over here. That is why the next thing, recheck your working. Do not be satisfied only after working once. Just go over it very calmly. So now we have all these lengths over here. That is the arc length. That is the length of BC. That is the quarter circle circumference. I added it all up. This is the answer. Similarly, add up all the areas. This is the answer. Make sure the answer is given finally to 3SF. Now let's look at this question. Which question is this? This is about AP and GP. It was a nice question. What was nice about it? I'll just explain you shortly. Now it says the first three terms of an arithmetic progression are 25, 4p minus 1, and 13 minus p, where p is a constant. Find the value of the 10th term. AP, the common difference is common. Second minus first, third minus second. That is what we have done. And we get this value. Now, when I solve this question and I achieve this value, I was kind of a little bit shocked. Why was I shocked? Because normally, yes, it could come out in a fraction. No one is saying that. It comes out to be negative, positive, and so on. But over here, what happened is that it's a very unusual number that came. So now expect the unexpected. Just focus on your working. Don't be overwhelmed that, okay, I mean, don't set any stereotypes in your head that the answer should come out to be this. No, it's not. As long as you're working is good, be confident about your working, and definitely, inshallah, you will get everything right. So be confident about your working. And let's move on. So now D comes out to be this. What is D? No, that is P. What is D? D goes over here. That's T2 minus T1. That again comes out to be a fraction. A is this thing. Now, when you calculate the 10th term, you get an exact answer. That means work in exact form. Do not round off, because our A was an integer. Our D was negative 74 over 9. And P was 40 over 9. P was 40 over 9. So now this thing was exact. This thing was exact. This definitely was an integer. Final answer came out to be exact. Now, if you would have rounded it off, your answer won't be correct. You would be losing accuracy marks. Now, the same question, same in the sense that the terms are the same. This time the examiner did what? They just changed the variable. And they are asking us the sum to infinity. It's a GP. Q is positive. Now, common ratio is the same. That's T2 over T1. This is T3 over T2. You equate, you solve, use a quadratic formula. There's no harm in that. Be very confident. Show all your working. Again, show all your steps. I did not skip any step. I showed that these two will add up. It will give me this. The square root of this thing is this thing. And there were two answers: reject the negative value, accept the positive value. Now, again, which is this? Which value is this? This is the value of Q. So let me write it down. This is the value of Q. So now plug in and obtain the three terms, that is 25, 15, and 9. Then obtain over here the common ratio, which is 3 over 5, and hence sum to infinity, which comes out to be 62.5. Does it mention anything about this exact form? No, it is exact, 62.5, so nothing to worry. So now this is all good. Let me just enlarge this. Now this one is about integration. And now it says, now look at this weird kind of curve. I mean, they give you the most unexpected thing. Now that is that don't be overwhelmed. Naturally, every question will look different. There will always be new type of equations. There will be new types of graphs. There will be everything new. But what is old? The old thing that are the concepts. So just focus on the concept and then you are all set on your path to success. So now over here, what happens? Over here, it says the diagram shows part of the curve with equation such and such, and the line x is equals to 2.4 and y is equals to 1. The curve intersect at the point 1, 1. Find the exact volume of solid generated when this shaded region is rotated 360 degrees about the x-axis. Now, when we will rotate it around the x-axis, and it looks beautiful if you write it like this also, that let's rotate it around the x-axis. There is a line over here, y is equals to 1. This will form a cylinder. You don't have to go into the mensuration detail. No need. This is just for curiosity. And then under the curve, whatever the area is, whatever the shape is formed, we don't care whatever that shape is. This volume of solid is between those two shapes. So now the limits are 1 and 2.4 for both of them. This is 1. We square it. We integrate it. We plug in the limits. Don't forget to multiply by pi. As simple as this. Leave the answer in terms of pi. It does not say anything about it, but that is the norm. So now over here, 5x minus 4 raised to power of negative 1/3. We square it, write one more step. Then integrate it using chain rule of integration. Take care of this coefficient of x also. Push all the constants on the outside. Plug in the value. Look at the simplicity of the question. They are not bothering us with a calculator. 8 cube root, that is 2. 1 cube root, which is 1. So only 1 is left. This is the answer. I converted this answer into decimals because this is exact. So there is no harm over here. This is exact. This is exact. 1.4 minus 0.6. This answer comes out to be 0.8 pi. Someone can write it as 4 over 5 pi. So all good, all clear. And how many marks is this? This is for 6 marks and they've given one extra page. I think I'm able to solve it very, very comfortably over here. Now, another question, which is about coordinate geometry, which is about circle equation. So circle equation is part of CG, coordinate geometry. The equation of the circle is this thing, already in the completed square form. The line with equation passes through the point and is tangent to the circle. Now, this is the equation of a line. It passes through this point. Isn't negative 9 the y-intercept? Yes. So therefore, negative 9, C is equals to negative 9. That is inserted over here. That is inserted over here. Now, I'm using it through the quadratics way. I'm solving this question through the quadratics way. That seems most realistic to me. This is the equation of the circle. This is the equation of a line. Form a single equation. So now when we form a single equation, because I have to apply the concept of discriminant, b square minus 4ac. So now what I did, now look at the working over here. This is where algebra will bog you down. So your algebra, your manipulation, your expansion, your factorization, your simplification, this should be of ultimate level. So let me draw a golden star over here. This should be of very, very high level. Without it, you cannot pass this particular question. So now what I did is this. I first expanded this thing and then inserted it, then expanded, then collected the like terms together, then applied the concept of b squared minus 4ac is equals to 0. So let me also write this as like ax squared. So this is ax squared. It's written before and after. This is bx and this is c, and that is what is getting the answer. So let me just write it properly. Hold for a second. I think I missed out something. Okay. So now this is ax squared. So what is the value of A? The value of A is 1 plus m squared. And what is the value of B? That is -6, -18m. What is the value of C? That is 72. Now I have taken negative common out because after squaring, it will disappear. Expanded, I got this. Either I use the quadratic formula or it just clicked to me that 36 into 6 is 216, and then 36 into 7 is 252. So I first simplified it, then I did middle term factorization. Now look at the question. It's about expansion. It's about further expansion. It's about middle term factorization or quadratic formula. It's about getting values of m, but the question is not over yet. What are they asking for? Find the two possible values of m for which line is tangent to the curve. B squared minus 4ac is equals to 0. For each value, find the coordinates. That means the x, the y. So now when m is 1, we plug in that single equation and we find the value of a, we find the value of b. We plug the value, the other value, -7, we find a, we find b. Now, when we have the quadratic formula, x is equals to minus b plus minus b squared minus 4ac divided by 2a, since it's tangent, this thing is gone and we are left with minus b over 2a. So I got the values of x. I plug in this equation with the correct value of m. I find the value of y, and that is how the working is done. So it took complete 2 pages. Just have a look at it. So now that's complete 2 pages. That's what you're looking at. So 1 page for the quadratics part, 1 page for plugging in the values of m, finding the value of a, b, and c, or someone can just find the value of a, b, and c and factorize. Naturally, you will get the same answer. If it's not necessary that you use it. Find the corresponding value of y by plugging in one of the equation. I found this one to be simpler. That's what I plugged in. And now we are on question number 11. What is 11? This is about increasing, decreasing, and it's about tangents and normals. So basically, it's about differentiation. It's about increasing and decreasing function. It's about tangents and normals. So basically, it's differentiation and coordinate geometry and increasing, decreasing. Now, another curve like this. So now it's kind of strange that we saw a curve in transformation, or maybe in like basic functions, and that almost, not exactly, had the same kind of pattern like this. Now it says a function fx is defined by such and such, does not equal to 0, because that is like an asymptote over here. The graph of fx is shown in the diagram. First part, find the set of values for which fx is decreasing. So whatever answer that you'll be getting, make sure that you write this thing over there. First of all, write it in the indices form. Second thing, differentiate. Now, this is one method that I've done. Over here, what I've done is that I've taken common. And then decreasing. So let me write over here, decreasing. Therefore, f prime x is less than 0. Now, this thing less than 0, no solution. This thing less than 0, simplify, and then factorize. And then for quadratic inequality, draw a sketch. Remember this thing, quadratic inequality. Therefore, draw a sketch. That is a must, not from the examiner, from my side, because that will ensure that you get the right answer. You don't get the right answer just by saying, okay, so now this thing is less than 0, this thing is less than 0. That's partial answer. That's not complete. That's not the proper strategy. You have to show a graph for quadratic, for cubic inequality, which you will study in P3, which I'll be teaching in my class. And in some classes I've already taught. So you get this answer and write this thing. Another approach, the same thing over here, but this time instead of taking common, I have taken LCM. And then this thing disappears. You have the same exact thing, and make sure that you write x should not equal to 0. So again, have a good look at it. And the last part, That was a good one. A triangle is bounded by the y-axis, the normal to the curve at the point where x is equals to 1, normal at x is equals to 1, and the tangent to the curve at the point where x is negative 1, tangent at x is equals to negative 1. Again, show. It's about show and tell. We will tell it by writing it out. We will show it by showing every single step. Find the area of this triangle. Give answer correct to 3 significant figures. What it's saying is that at a particular point, if I draw a tangent and if I draw a normal and they are intersecting and some kind of triangle is created, so find the area of that triangle. Read it again. A triangle is bounded by y-axis, the normal to the curve and tangent. It's not about diagram. It's about getting the hang of it. Find the area of the triangle, give your answer correct to 3 SF. This time it's not asking an exact form. It's definitely asking in decimals because decimals are part of life. Fractions are part of life. You have to be well versed in both. Now, if x is equals to 1, I plug in the original equation. I found the y coordinate. I plug in the original equation. X is equals to negative 1. I found the y coordinate. Then I plugged it in the derivative. That's the equation of the tangent. But over here in blue color, I need equation of normal, which is 1 over 9. So I have 1 over 9. I have 1 comma 3. I found this equation. Similarly, I have the coordinate. The gradient of tangent is coming out to be negative 9. Coincidentally, it's coming out to be the same. I think probably because of symmetry of this graph. And we get this particular equation. Now, line meets y-axis, x coordinate is 0. For this thing, the y-intercept is 0, 26, 9. And over here, when x is 0, y is negative 8. Now, the blue line meets the green line. The normal line meets the tangent line. Let's solve this. And again, another fraction that is coming your way. Now, at this point, work in fractions. And at the very end, then convert in decimals. Okay. So now what do we have? We have 0, negative 8. We have 0, 26 over 9. We have negative 49, 41, 0. Negative 49, 41, 0. So this is negative, but I have removed the negative sign. Why? Because I'm talking in terms of distances. Now, this thing, from this perspective, this thing is the base. That's the difference between these two. This thing from the y-axis. By the way, this is the y-axis. So this is the y-axis. And let me draw another line like this. No, that's too thick. Let me draw another line like this. And this is the origin. And let me just highlight this. So this is origin and this is the x-axis. So the diagram is formed on the other side. So now what do you see? What we see is that we have the base that is 26 over 9 minus 8. So that is this thing, that's the base. And this thing becomes the height. So area half into base into height, half into this thing, into this. Again, I can use a calculator at this point. I just have a habit of simplifying things. I just love fractions. So what I've done is that I've taken LCM. And this is what I get. Now, at this point, I plug everything in the calculator, and this is the answer in 3 significant figures. This was just multiplying these two, and these 3 multiplied as this thing. So if they wanted an exact answer, I would stop over here. If they wanted a decimal answer, this is the level of accuracy that I would go to. So that is some of the things from my side. That's the paper May, June 2024, variant 11. I think this is a pretty nice paper. And I think it was not difficult as such. There were some strong parts, very, very slightly strong parts. And overall, the paper was a very moderate, easy to moderate paper. Well, I won't use the term easy. People would be offended by it. So I think I'll just use the terminology moderate. It was definitely not a difficult paper. So thank you for watching Mathematics with Shahab Yaqub, and stay tuned for more papers. Take care.